Hello everyone, I'm Dr. Kavita Jia. We will talk about CCN Lab Experiment 4. Let's have a look at the aim of the program. For a given data, use CRC CCITT polynomial to obtain the CRC code and verify the program for the cases without error and with error. So CRC stand for Cyclic Redundancy Check and CCITT stand for Consultative Committee for International Telephony and Telegraphy. As we are well aware that CRC works at data link layer and it has three major functions at the data link layer: framing, flow control, and error control. We also know that the complete action of error control is not achieved in the data link layer, but to an extent the error can be detected here. So in the data link layer, the error control implies that there is a possibility of detecting the errors, but does not have the ability to correct the errors at this stage here. So before discussing about the program, let me explain how the CRC calculation is done here. So if you want to send any message from a transmitter to receiver, so here we are going to use a generator polynomial, and here we'll be having the data message that will be 1110010 here. So here the both the side will be having same generator polynomial, means we'll be having same generator polynomial value at the transmitter and the receiver here. So here the length of the generator polynomial we are going to considering it as an 5. So whatever the size, we have to make the 5 minus 1 bit. Means we will be going to get 4 bits here. So that bits we have to append this 4 zeros to this our data message. So means like we have to count the length of the generator polynomial, and we are going to considering n minus 1 bit here. So now we have to perform the XOR operation. The result of XOR operation we are all well aware of that. So only when any one of the input is high, the output will become high here. If both the inputs are logical 0 or a logical 1, the output will become 0 here. So next we'll be proceeding with the CRC calculation. So first bit will be 1. So I'm going to considering here 1. I'm multiplying with this one. So what I'm going to get? So 1 1 0 1 1 here. So if I'm performing this XOR operation, so here 1 1 is 0, 1 1 is 0, 1 0 is 1, 0 1 is 1, 0 1 is 1. And here the first bit what we got is a 0. The first bit of your checksum is 0. We have to exclude the initial bit and we have to left shift the other position, means the first bit we have to discard here. So here what we are having only 4 values, and my generator polynomial length will be 5 here. So I'm going to considering here the next bit. I'm going to considering this as an 1. Again I have to perform the XOR operation for this bit here. So if this is in 0, I'm going to write it as in 0. Anything multiplying with 0, I'm going to get 0. Again we have to perform the XOR operation. So if I'm performing the XOR operation, the first bit is 0, I'm going to discard it. So again we got the 4 values. So I'm inserting 0 here. So this first bit is 1. So I'm mentioning here and multiplying with your generator polynomial, I'm going to get 1 1 0 1 1 here. So if I do the XOR operation, again the first bit is 0, I'm going to discard this bit. I perform this remaining bits XOR operation, I'm going to get these values, and again I have to insert this 1 to make the generator polynomial length will be equal to your data message. So this bit is 0, again I'm going to considering it as a 0 and performing the XOR operation. First bit is again 0, so I have to discard this bit and I'm going to considering this 1 0 1 1 here. So to make this equal length, so I'm going to insert 0 here and perform the XOR operation for this. So finally we are going to get 0 1 1 0 1 0 here. So if this bit is 1, so I'm going to considering this multiplying with this generator polynomial, I'm going to get 1 1 0 1 1 here. So if it is in 1 1 is 0, 1 1 is 0, 0 is 0 is 0, 1 1 is 0, here 0 1 is 1 here. So again what we have to do? So first bit we have to discard. So all these remaining bits are zeros here. So here we'll be adding with remaining bits will be 0 0 here. So I'm going to considering as it is. So I'm going to considering my checksum value will be 0 1 0 0 here. So Here the data plus CRC are a checksum value we have to send to your receiver for the calculation purpose here. So in the receiver side, what we are going to considering previously in the transmitter side, we are going to considering this data message as with your generator polynomial n minus 1 value. But here instead of this n minus 1 value, we are going to considering this checksum of your transmitter and we are performing the XR operation. So here at the receiver, the checksum is being generated by dividing the transmitted code word with the generator polynomial. It must be return remainder of n bit will be 0 here. Means this is a successful transmission. Because we got CRC is equal to 0, we are going to considering as a successful transmission. Suppose the remainder obtained is a non-zero value, then the received frame is corrupted and it must be discarded here. So now let's see the program. So here we are including the header files here. After including your header file, so we are going to define it. We are going to define an n. So we are defining the n means n is a global variable holding the length of your generator polynomial here. So here we are considering some characters in an array. T is nothing but your transmitter, CS is your checksum, G is nothing but your generator polynomial value, and here we are going to considering some 128 bits of dummy variables here. So here we are initializing with your some variables to perform the XR function here. So here the excluding the bit 0 bit by bit comparison of your checksum to your generator polynomial here and function to process the generation of CRC code here. So whatever the content of data T is now copied to your checksum with the help of the variable E here. So only the first bit of the checksum is 1, then perform the XR operation. If CS of 0 means the first bit is equal to 0, they exclude the initial bit and left shift to the other position here. So here from the variable t, we have to determine the checksum here. So whatever the length I have to enter to your keyboard here. So here we are going to enter the data, means ask the user to enter the n bits data here, and we are going to display the predefined generator polynomial value here. So here we have to compute the number of bits in the data in your string length that we are going to considering as a string length here. So in the next line, we have to limit the length of the data. How we are going to considering? So it's less than a plus n minus 1 means we have to appending the n minus 1 zeros to your existing data here. So after this, we have to display the complete data with zeros to be padded to your transmitter. That will be the modified data here. So once we are done with, so we have to perform the CRC calculation and we'll be displaying the calculated CRC code at the transmitter here. So here we have to append the checksum from the CS of E minus A to actual n bit data to get the final data frame here. Means we'll be appending the checksum value to your message data message at your receiver part to calculate the checksum here. So once we are done with this CRC, so what we have to do, we have to display the final transmitted code word. Once we are written this, we have to give for user choice to give an error free transmission or an error transmission here. So when there is an error here in the transmission, what we have to do, we have to enter the position where the error is to be inserted here. It means if the data entered position, bit position is 1, so we have to replace with 0 and vice versa. If bit position is 0, we have to replace is 1 here. So finally, we have to calculate the checksum at the receiver here. So here we are using the comparison of your string here. So means we are padding an array of your dummy variable with 0 here. Means we are making the variable length to be equal to your checksum by using your dummy variable. So we'll see the output of this program. So we have to enter cd document, program file name and GCC of your file name. dot slash your file name. That will be your CRC here. So what is the data we have to enter here? So that data message will be 000 101 will be my data transmitted, and my predefined transmitter, the generator polynomial will be 11011 here. So once we are getting this generator polynomial, again we'll be get the modified data by appending n minus 1 of your generator polynomial. That will be your modified data. So the checksum value what we got at the transmitter, it will be 0100 here, and the final code word. So how we are going to write here? So till the 11100 101 will be my data transmission, and this is my checksum value. So it will become my final code word value here. So we have to test the error detection, whether we have to give the error or not. So I'm going to give press it as an 1 here. So we have to enter the position where the error should be inserted here. So I'm going to mention it as an 2 here. So what we are going to get here? So here the first bit, so that is 0, 1, and the second position. So instead of 1, it says make it as an 0 here. Means we are going to enter the position 2. I have inserted 0 here. 1, 1, 000 101 and 0110100 will become my erroneous data here. For this again we have to calculate the checksum. So it will become 1000. So means error is detected here. So without error, so it will be my checksum value will be 0100 here. So here how we are going to find the error here. So if I don't want to get the error in this data, so we have to press 0. So it's going to give there is no error in the data what we have transmitted to your receiver here. So thank you for watching this video.